All right, next thing, 9.3, adding and subtracting rational expressions. Adding and subtracting rational expressions. So it's all going to start with adding or subtracting fractions. What happens to students? All right, we've been multiplying, we've been dividing. Now we're going to start adding, and you get the two confused. And you can't do that. Adding fractions isn't hard. Add the numerators, put them over the common denominator. When you see adding fractions, your first thought has to be, do I have a common denominator? Do I have a common denominator? And if you don't, you got to get one. That's always your thought. If I'm adding, I need a common denominator. Once I get it, add the numerators, put them over the common denominator. So here's the rule. You got an A over B, plus or minus. I'm doing two at once, right? I'm doing addition and subtraction at one time. C over D, hey, I don't have a common denominator, so I got to get one. What does the bottom need of the left fraction? It needs a D. And you're always looking at the bottom. It's the bottom that you're concerned about. The bottom is the key because the bottom's the denominator, and that's what you need to be common. And of course, whatever you do the bottom, you do the same thing to the top. So you're going to multiply the left fraction by D over D. And you look at the right fraction, and the right fraction needs a C on the bottom. Because again, it's all about the denominator. It's all about the bottom. And a B on the bottom. No Kool-Aid for you, right? B on the bottom. This one has a BD on the left. We need a BD on the right. Whatever you do the bottom, do the same thing to the top. Now we have that common denominator of BD, right? And we have now the left numerator of AD and the right numerator of BC. Just turned out that way. All right. AD plus or minus BC over that common denominator of BD. It's all about the common denominator. Look, some of you are still in your mind think that you can't do fractions. That's your problem. You think you can't do fractions. I'm just telling you again, there are three things with fractions. When adding or subtracting them, get a common denominator, add the numerators, put them in the common denominator, number one. When multiplying them, top times top, bottom times bottom, reduce before you multiply, thing number two. When dividing fractions, invert the second and change it to multiplication. Top times top, bottom times bottom, reduce before you multiply. Thing number three. That's it. Three things. You telling me you can't remember three things? But here's the problem, though. Some of you do get confused over those three things. You cannot. You can look. If you got to write a memory card out, write a memory card out. Whatever it takes, but you can't get confused on how to do fractions. It's too easy. Adding, subtracting. Add the numerators, put them over the common denominator. Multiplying, top times top, bottom times bottom. Dividing, invert the second, top times top, bottom times bottom. That's it. All right, now you might make a mistake or two occasionally in executing that. All right, that's a mistake. But you should know what to do. There's no reason not to know what to do. It's too easy. Okay, so let's get rolling into now the polynomials. All right, I don't know why it changed yellow on me. Whatever. All right, so here's the first scenario. So you look at this, you say, oh, I'm adding fractions. All right, that's your first thought. And where are you looking? You're looking at the denominators, right? That's where you're looking. You're looking at the denominators. And you say, I don't have a common denominator. And you say to yourself, what can I do to get a common denominator? And hopefully you would say, all I need to do is on the second fraction, I need to multiply the bottom by x. Because that'll get me an x squared. And whatever you do to the bottom, do the same thing to the top. Now add the numerators. What's the left numerator? A 2. What's the right numerator? A 3x. What's the bottom? An x squared. Add the numerators, put them over the common denominator. Do not cross out those x's. Don't do that. You can't do that. Why can't you do that? Because the 3x is tied into the other thing, right? It's a binomial. It's all one thing. You can't do that. Can't do that. Can't do that. So that's it. You're done. 2 plus 3x over x squared. Some purists might say, hey, put the 3x in front and the 2 in the back. And that's true for the very, very purists. But again, in this chapter, time is a consideration of everything you're doing because it takes time to factor. And if we're going to be able to assess if you know what to do, we can't have you taking time that we already know you know how to do things. So again, I'm not going to nitpick over the order. But if you're a purist and you want to be excellent, then technically you would. All right, so again, you look at number 2. And again, where's your focus? Your focus, of course, is looking at the denominators, right? 6n there, and a 15n. It's going to fade away, so. And a 15n there, and it's all about the denominators, and I shouldn't have selected the stupid pen because now I can't get off of it. All right. Did it go away? It went away. So again, you're looking at the denominators, right? All about the denominators. So now you got to decide, what do I have to do to get a common denominator? In this case, we're going to do something to the left side. What are you going to multiply? All right, so let me say it this way first off. Are the variables good? Left have an n, right have an n, we're good. So it's the numbers. So how do you reconcile a 6 and a 15? We're heading toward 30, right? So that means you got to multiply the bottom of the left by 5, right, to get to 30. And whatever you do to the bottom, you do the same thing to the top. And again, we're looking at the bottom on the right, and we got to get to 30. So we're going to multiply the right one by 2. Whatever you do to the bottom, do the same thing to the top. Okay, I'm going to show the middle step here, just for clarity's sake. This is Algebra 2. I'm not saying you need to show this step. I'm just saying I want it to be clear in the notes. So the left is a negative 25, right? And the right fraction is a negative 6, and that's all over the 30n, the common denominator, right, of 30n. Everybody with me? Right? The left was a negative 25, negative 5 times 5. The right's a negative 3 times a 2, a negative 6, all over the common denominator of 30n. And now I need to simplify this to a negative 31 over 30n. If that reduced, would I reduce? Of course. Right? You always reduce if you can. It doesn't, but sometimes it will. Sometimes you'll be able to reduce, and you will. You'll look. This one doesn't reduce. So common denominator, add the numerators, put them over the common denominator. All right, let me show you this one, because you may not see the trick on this one. There's an easy way to do this one, and there's a hard way to do this one. You don't want to do it the hard way. You definitely want to do it the easy way. Anybody have any clue? Again, you're looking just at the denominators, right? It's all about the denominators. Abigail?
You would switch the order on the second fraction denominator and then take out the common.
Okay, so if I switch the order on this, you guys had a homework problem similar to this a couple days ago. At least I think the extra students did. I'm just going to switch the order first, just to be clear with you, right? Commutative property, I put the negative x in the front and the positive one in the back, commutative. And then I'm going to factor out a negative 1. That's going to change the negative x to positive x and the positive 1 to negative 1. So I factored out a negative 1. Well, I still have a little bit of an issue, right? I still have that negative 1 down in the denominator, so how would you care for that? Just stick it in the top. Just stick it in the top. Look, what's a 5 divided by a negative 1? A negative 5, which is the same as a negative 1 times a 5, right? You just stick it in the top. So, all right, now we're good. Now we got a common denominator. What's our common denominator? X minus 1. Awesome. Now we're going to add our numerators. Hey, be careful, distribute. Let's put our variables first. Would you agree there's a negative 3x? And would you agree you end up with a 2 minus 1 for a positive 1? Now again, if you can't do that in your head, do the extra step. Negative 1 times 3x is a negative 3x. Negative 1 times a positive 1 is a negative 1. 2 plus negative 1 is 1, right? You got to add the numerators, put them over the common denominator. Questions on that? Julia.
For number 2, let me get this straight. So when you can reduce because the 30 is multiplied times the n?
If you reduce, the only reducing will happen at the very end. This is what I see students do, and it gets them in big trouble. I see students like getting a common denominator, and before they're done, they reduce the common denominator back out. Because that can happen sometimes. Don't do that. All right? Your whole purpose was to get a common denominator. So I don't know if this was your question, Julia, but it made me think of that because I've seen students do that. They work towards a common denominator, then they reduce it. Or sometimes something has a common denominator already, and they can reduce, and they reduce out and ruin their common denominator. What in the world, you were there? So anyhow, always at the end you look to reduce. So it's at that step. It's at this step I'm going to look to reduce, but I can't again because that's a binomial divided by a binomial. They're not the same. Did that answer your question? All right, good. Anybody else? Questions? Okay, let's go to the next one. I think I got to get rid of my shade so I can go higher. Okay, so number 4 here. Keep working through our progression. All right, so number 4. Now you look at the situation, and now this is a little different. When I look at the left, it's not an n times a p. If it were, I'd multiply the right by n. It's an n plus a p. They're tied together. They're one thing. Here's the analogy. If I had 2n over, let's go with, I'll go 13, minus 4 over 7, that's the kind of problem this is. The n is plus the p. So I got to multiply this one by something. What would I multiply the bottom of the left one by? Anybody know? Okay, let's go over here. What would I multiply the 13 by on the bottom on the right? 7. Whatever I do the bottom, do the same thing on top. So what am I going to multiply the n plus p by? I got to multiply that by p. This is one thing. This is a quantity. It's tied together. I have to. Here, I'll make the analogy like this. I'll change the 13 into a 5 plus 7. How about a 6 plus 7, brother? I'll change the 13 into a 6 plus 7. Isn't that a 13? Wouldn't I still have to multiply the left by 7 over 7? I would. Just because that's an n plus, it's an n plus a p. So whatever I do the bottom, do the same thing the top. Whoops, green, no big deal. And what would I multiply the right by? Say it if you know it. N plus p. Look, this is all about the LCD. Remember those? Least common denominator, which comes from the LCM, the lowest common multiple. And I'm going to show you this here in a minute with a little bit more complicated one next. All right, but this one then has quite a bit to finish this. Okay, the common denominator is set. It's either an n plus p times p or a p times n plus p. It doesn't matter the order. I'm just going to go p times the quantity n plus p. And again, I know this is simple, but for time's sake, we'll just leave it factored. And besides, if it reduces, you want it factored. So that's the common denominator. The left side is what? Oh, I've never finished my n plus p on the top, right? And I'm going to use a parentheses to keep things clear. Just to be clear on this one, The left is 2np, agreed? The right, take your red there, is a negative 4 distributed, right? Minus the 4 times the n plus p. So you end up with a negative 4n minus 4p all over the p plus n over p. If anything added on the top, we would add it up. But you can't add anything there. Nothing's like terms, right? And again, if I could reduce, I would reduce, but the top is a trinomial, one thing, and the bottom, nothing divides into it. And so that's the answer on that one. 2np minus 4n minus 4p over p plus n over p. Abigail.
Would you factor out the common 2?
You could, but there's no reason to. So if I ended up with a 2 on the bottom, I would definitely factor out the common 2 and reduce. But because there's no 2 on the bottom, I'm just wasting my time. Now, if you do it, I won't take off, but you're wasting your time, and time's precious. So you have to be careful in your factoring and taking time to factor if it doesn't give you anything of value. So when you look at that and say, oh, there is a common 2, but there's no 2 on the bottom, I don't need to do it. That's your thought process. Great question. Jeff?
Why did you distribute the 4 and not just leave it as like one whole 4 times 1 n plus p?
Because when you're doing addition or subtraction, you do have to finish adding or subtracting the numerator. And it's a common mistake that students do. They try to leave the numerator unfactored. You'll see that more clearly on the next example. So keep that question in mind. Let me do the next example, and you're going to see why we got to finish that out. Because it looks going to be completely different when we do. But the reason is you have to finish adding or subtracting the numerator. It has to get done. The denominator can stay factored. Okay. Any other questions before we go on? Good. Keep asking them. All right. Let's do this next one. Now we're stepping up another level. So the original is in black. For time's sake, I've already factored the denominators. So that trinomial became x minus 4 times x plus 3. And this right denominator was a difference of 2 squares, and it became x plus 3, x minus 3. I already factored them. All right, we're going back to old school LCMs, LCDs. Going way back to pre-algebra, and I did review this in Algebra 1. How do you figure out the LCD? You list your factors, you line up common factors, and the LCD is one factor of any group, right? That's the LCD. X minus 4 times x plus 3 times x minus 3. Some of you that you see math clearly in your mind, you won't need to make a chart like this and say, oh, that's the LCD. You'll see this. You understand it from what you have as of the factors. But others of you don't see it, and you're going to have to make a chart. Okay, again, you list the factors. I put the x plus 3 under the x plus 3 because they're the same thing. And anything not the same has to have its own space. And then every column gets represented in the LCD. Every column. Now all you do is look and see what's missing from the LCD. So here's the left denominator, right? The x minus 4 and the x plus 3. What is it missing? It's missing an x minus 3. So that's what I need to multiply it by to get it to be the LCD. I got to get it to match the LCD. And whatever I do to the bottom, I do the same thing on the top. Does everybody know why I chose the x minus 3? So again, let me one more time show you. With the look at the right at your LCD chart. The top right here is that left denominator. And it is missing this x minus 3. That's why I'm multiplying it by x minus 3, the factor it's missing. So if you take that in mind, what are we going to multiply the second denominator by? X minus 4, right? What it's missing. Now we got a common denominator. All right, so watch. Here's the common denominator. X minus 4 times x plus 3 times x minus 3. Oh, it's the LCD, right? The lowest common denominator, or least common denominator. All right, so Jeff, watch on this one. 3 times x, 3x. 3 times negative 3, negative 9. I'm going to do the second one in black. I'm always coming and catching that negative if there's a negative there, right? So I distribute the negative 2. Negative 2 times x, negative 2x. Negative 2 times negative 4, positive 8. Now I need to finish adding the numerator, because this is an addition of fractions problem. Add like terms. 3x minus 2x is x. Negative 9 and positive 8 is a negative 1. And guess what? Every once in a while, this will reduce. This one doesn't. But every once in a while, it will reduce. And that's how those will look. Usually you'll get a trinomial or a binomial on the numerator over numbers of factors in the denominator. Any questions on that? Josh? Yes. If there would have been an x minus 1 on the bottom, we could have divided them out. That would have left a 1 in the top and whatever was left on the bottom. All right? Okay, let's keep progressing here. So again, I wish I had a little bit more time. But when you look at a full-blown problem like number 6, you've got to say to yourself, I got to factor the denominators. I need to know the factors so I can figure out the LCD. All right. So I know 2 binomials, x and x, right? So again, when I'm thinking of negative 12, I'm thinking of a positive 1 in the middle. So how about like positive 4 and negative 3, right? That gives you that positive 1x in the middle. Factoring the second, I got a 2x and an x. Be careful with the 2. It's going to be a multiplier. I always think of this outside one first, right? I'm always thinking outers. So I have 9 or 3. Well, 2 times 3 is 6. And that leaves the other 3. 6 minus 3 is 3. And I need the 6 to be negative, right? And the 3 to be positive. And that's the factoring of that. So again, students that don't see it, you're going to list x minus 3, x plus 4, right? And then when you list the second one, you're going to line up the x minus 3's. And you're going to stick the 2x plus 3 out to the right, right? Because there's no column to put it under. And now you see the LCD, right? The x minus 3 times the x plus 4 times the 2x plus 3. So what's missing on the left fraction? So that's what we got to multiply by, 2x plus 3. Whatever you do to the bottom, do the same thing to the top. And again, by the way, look at a couple things here that will help you. So let me give you a second, then look up at the screen. Hey, on the bottom, I got that parentheses. Include the parentheses on the top, and guess what? Go over to that other numerator, being it's a binomial, and put it in parentheses, because the way you do fractions is top times top. So that's 2 binomials you got to multiply out. On the left, again, what are you missing? And you say it's an x plus 4. Whatever you do to the bottom, do the same thing at the top. I keep giving you guys subtraction because subtraction's harder, and I'd rather do the examples of subtraction. It's easier to distribute a positive. All right, so watch. In a problem like this, and I have no problem with you guys doing this in homework. There's my denominator right now. I'm not even going to bother to write it because I know I got to go one more step. And so I'm just going to give a squiggle there. It's the common denominator. The top left, you're multiplying two binomials. Algebra 2, can we do this in our head by now? X times 2x is 2x squared, agreed? But do you agree I'm going to do the outers a positive 3x and the inners a negative 2x, and I'm going to add up those common terms, right? Which is a positive x in the middle. We should be able to do that in our heads by now. If you can't, multiply it out longhand, all right? If you can't do that. And then the last distribution, negative 1 times a positive 3 is a negative 3. That's all the left binomials. Let's do the right. I'm going to do the right in green this time. Negative 3 times an x is a negative 3x. And negative 3 times a positive 4 is a negative 12. Now I got to add the numerators. I got to add up all the common like terms in the numerator. So I end up at 2x squared minus 2x minus 15 all over x minus 3, x plus 4, 2x plus 3. And now I have to say to myself, self, does the numerator factor? See, these get to be time consuming. So I got to think 2x and x. So I'm thinking, I got to look. Here I'm doing red. I got to look. 2x and x. Right. Thankfully, 15 is either 1 and 15 or 3 and 5. All right. So if I go 3, that's a 6. A 6 and a 5 won't get me to a 2. If I go 1 and 15, a 2 and a 15 won't get me to a 2, and a 30 and a 1 won't get me to a 2. Shh. No reducing, that's the answer. Right? But you do have to look. And by the way, if you don't reduce, it's going to be a minor deduction, but I will deduct. It's usually a point. But you do have to look. All right, time is flying. Abigail.
It factored, and then one of the factors was in the denominator.
Then you would divide those out, yep, and that would leave whatever's on the top and whatever's on the bottom. And again, you'd leave the bottom factored, whatever's left with factors. I don't know if anything here is going to, yeah, we'll finally get something that reduces here if I get to it. So, all right. Next situation is now we got a whole new category. Here, you might want to do some kind of dotted line to make sure you understand now we're going into new territory. Now I got a binomial in the denominator, but it has a fraction. It's a compound fraction. Okay, take your green. It's important you recognize where your problem is right there. That's my problem. That denominator, the fraction in the bottom of the fraction. It's no good. Can't have it. How am I going to get rid of it? I'm going to multiply this whole bottom by x over 1. Will that take care of that x? I'll show you in a minute that it will. And whatever I do to the bottom, I got to do the same thing to the top. Now I put it on the left instead of the right because you guys distribute better from the left than the right. And here's where students will get in trouble. They'll try to do this only to the 1 over x. But you technically have to do it to the whole bottom and the whole top. Whole bottom, whole top. So let's distribute. And here, before we do anything, the top's easy, right? X times 2 is 2x. No problem on the top. Let's keep the bottom in green. X times 4 is 4x. And what's an x times a 1 over x? It's a 1, so you get plus 1. See, we took care of the problem. Do we any longer have a fraction over a fraction? No. So we no longer have a complex fraction, and that's what we were after. Please don't cross out the 2 with the 2 of the 4 in the bottom. 4x is tied into the 1, right? They are married. No divorce. All right? You can factor out, but you can't. All right, so that's it. That's all you're going to do. That's the answer. 2x over 4x plus 1. Done. We got rid of the fraction in the bottom of a fraction. Step it up a level. Oh, man, we got a fraction in the top and a fraction in the bottom. Now we have two issues. We have the n squared down below, and we have the n on the bottom of the top. Our denominators are the problem. It's all about the bottom, the denominator, all about the denominator. So, what could you multiply the top and the bottom by to take care of both problems? Any idea? N squared, exactly. If you do the bottom by n squared over 1, that'll take care of the bottom. And if you do the top by n squared over 1, it'll take care of the top. And look, we got to do the same thing, top and bottom. You can't do the bottom by n squared and the top by n. You just change the value. Multiplying by 1 changes nothing. So, but it's got to be 1. All right, now you got to distribute. So notice I'm putting these in parentheses. Will some of you not put them in parentheses? Yes. Will some of you get them wrong? Yes, because the devil's in the details. I don't know where that saying came from, but it's all about the details. It's the details, the details, the details. All right, so distribute. N squared times 1 over n leaves you an n. Do you agree? And an n squared times a positive 2 is a positive 2n squared, right? We'll do the bottom in green again. N squared times a 3 is a 3n squared. And an n squared times a 1 over n squared is a plus 1. Can we factor a common n out of the top? Will it do us any good? No, so I'm not going to do it. Can you factor the bottom? Only if you really contort this into a difference of 2 squares, which would leave you a square root of 3 in the front of both terms and imaginary numbers. Take care of the plus, so we're not doing that, right? All right, so that one's done. Done. Next scenario, kick it up another level. Oh, man. We're never going to have time for this one. Maybe. I got to go fast. Let me get rid of my shade because I got to go higher for you guys. Oh man, I got one more yet, and then there's another page. Guess you're gonna be watching a video for the rest of this lesson. Sorry, but or don't watch it and just try to do the problems on your own. I mean, it's fine. You can do what you need to do. All right, so let's take a look at this one. Problem. We got 3 problems. All my bottoms, all the denominators are the problems. What can I multiply the bottom by to get rid of the problem? AB, right? The B will take care of the first one, and the A will take care of the second one. And again, whatever I do to the bottom, I better do the same thing at the top, and doesn't that take care of the problem on the top? It does. Beginning to catch on with these compound fractions? So what is the top? AB times 1 is AB. AB times an A over B, the B's divide out and you're left with A squared. So we got an AB plus A squared. Bottom. The B's divide out and you get A squared. And the A's divide out and you get negative B squared. I'm going to factor out the common A out of the top, and that leaves me a B plus A. And the bottom is A, difference of 2 squares, plus in the middle of one, minus in the middle of the other. Square root of the first, square root of the last. And lo and behold, we can finally cross out the B plus A and the A plus B, right, are the same thing. Final answer, A over A minus B. That one reduced. Number 10 is like 5 lines of stuff. You could only have like one of number 10 on any given assessment. And like you can't have a whole lot of other stuff with it. Because it's long. All right. Look. Problem. 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 We got lots of problems. Poor dear. Full of problems. Problems everywhere. All right. We got to multiply top and bottom by something that will take care of every problem. Who wants to go for it? Come on, you can do it. What are you going to multiply by? Come on, somebody. Hey, you can't get the glory without the guts. All right? Look, is anybody else volunteering? No. Does anybody else expect to get the answer? No. So if you don't get it, is it any big deal? No. You're normal. But if you get it, then you get the glory. So who's going for the glory? Come on! Go for the glory! Josh, go ahead, Josh. Say it again. Anything else? One more thing. Missing one thing. What's he missing? X. You need the X. Because an X plus 1 doesn't take care of an X, and an X plus 2 doesn't take care of an X, and X takes care of an X. Right? The X on the top is cared for, the X plus 1 on the top is cared for, the X plus 1 and the X plus 2 on the bottom are cared for. Whatever you do at the bottom, do the same thing at the top. X plus 1, X plus 2, X. Oh, this is going to be fun. All right, got to distribute. What do you get on the top? 8 times X plus 2. That's only the left. I rearranged things a little bit. The only thing that crossed out with is the X plus 1, right? 8 times X plus 2. And you got to multiply all this stuff out. Then what do we have? A negative 4, the X's divide out, times the X plus 1 times the X plus 2. That's a big numerator. And we got to multiply all that stuff out. What's in the bottom? Is the bottom any better? All right, the left is 4x times x plus 2 minus a 2x times x plus 1. But look, it's just algebra from there, right? It's just multiplying and adding like terms from there. So we don't have time. Wow, this thing even reduces. What an awesome problem. This thing actually reduces when you're done. You got to factor the trinomial in the top and take out a common 2x out of the bottom, and it'll divide out. What an awesome problem. It's great. Math is awesome. All right. Is that complex? Yes. Hey, is that doable? That's doable. Yes, that's doable. Notice these last, hey guys, notice these last few are this different category, right? Don't mix up the two categories. Now, unfortunately, I had to do by video. I got to talk to you guys about the arithmetic mean, which that's no big deal, but that's a little tricky. I'll do that by video. But this is something you have no clue about, and it's called the harmonic mean. All you musical people. The harmonic mean. Awesome. I'll do it by video. You see your homework there. It is due Monday.